Mutable values can be used to define mutable functions. So here's a function with behavior that varies over time. That's what makes it mutable. Every time you call it, you get a different result even with the same argument. Let's say we want to have a function that represents a bank account that has an initial balance of $100, and then I want to be able to withdraw money from my bank account, so I call it on the amount I want to withdraw. And what is the bank account here? Well, it's just the withdraw function that's representing the bank account. When we withdraw 25, how much would be left over? $75. So the argument is the amount to withdraw, and the return value is the remaining balance. If I withdraw another 25, then the remaining balance should be 50. A second withdrawal of the same amount leads to a different return value. This is a mutable function. It is not a pure function because something is changing as a side effect of calling the function. The withdraw function's behavior is the thing that's changing. Somehow, this withdraw function is representing some information, some state we call it, which is the balance of the bank account from which we are withdrawing. And we describe that state as local to the function because I didn't write it down anywhere else. Instead, it's just part of the function and therefore defines its behavior. If I withdraw 60 and I only have 50 left, I might get a return value like, oh, there aren't enough dollars in your bank account for you to do that. But if you withdraw 15, that's fine, and it deducts it from 50. Where is this balance stored? It's within the withdraw function, which we create using a higher order function, makeWithdrawList, that takes in the initial balance. The place that we will store the balance is within a list referenced in the parent frame of the withdraw function, that is the makeWithdrawList frame. And since it's a mutable list, we can change the value contained within it every time we call withdraw. So what you're supposed to appreciate from this example is that we have created a function that bundles together some behavior and some data, but unlike previous examples, the data is changing every time I call withdraw. And that's just a natural consequence of having mutable values in my programming language, is that I can have behavior change over time as well. So how do we achieve persistent local state, meaning that there's a balance associated with the withdraw function that persists across multiple calls to withdraw? So if I call it multiple times, I'm accumulating information. Well, I do it with a mutable value. Here's the implementation. I define makeWithdrawList, which takes the initial balance, creates a list with the balance contained within it. The contents of B can change because B is a list, and in fact, the contents of B can be changed even from within the body of the withdraw function. As long as a function can refer to this list, it can change it. So withdraw is a function that takes the amount to be withdrawn, checks to make sure that there's enough money, and where does it check? Well, it actually doesn't check the balance, which will remain unchanged. That was the original balance. It will check the element at index 0 of the mutable list B. The amount is too large, then we're done, but if not, then I reduce that value by assigning a new value, and that's the new balance which I can return. MakeWithdrawList returns the withdraw function, whose parent frame is the makeWithdrawList frame, which has a B referring to a mutable list containing the updated balance, which was originally the balance passed in, but later will be reduced by the amount that was withdrawn. If I call withdraw twice, I'll always use the new value for B0, which was updated from the previous call. So here the name is bound outside of the withdraw def, but element assignment changes the list by referring to that name, and you get an environment diagram that looks like this. MakeWithdrawList was called with a balance of 100. It defined a B, which is a list, which originally contained 100, and then defined a withdraw, which is a function whose parent is F1, the makeWithdrawList frame, which means that the body of withdraw can refer to this B. it can also change that b. Withdraw was returned bound to the name withdraw, then called on the amount 25, which checked to make sure that 25 was not greater than what was in this list originally, which was 100. Then it reassigned the contents of the list to be 100 minus 25 is 75. Withdraw doesn't reassign any of the names within the parent, because that's actually not how assignment works. Assignment statements, like b equals, always assign in the local frame. That's actually not strictly true. In Python, there are ways to assign to non-local or global frames using statements called non-local and global statements. You can read about them if you want, but we're not using any of those here. Instead, what we're doing is referring to b, which is always the same b. It's always the same list. It's just the contents of the list is changing over time. So withdraw doesn't change what these are bound to. Instead, it changes the value of b itself. And as a result, I used the mutable value, something built into Python, in order to create a mutable function.